2 more classes. And if that isn't good news for you, then maybe this is. There are no more assignments. I don't have anything due for you this week. I am not giving you any new material or anything you have to turn in. I have given you a study guide that is posted, and I'm hoping you brought it with you today. I'll be pulling that up here in just a second. But I have not made the study guide a grade. So instead of making the study guide a grade for you and making you do it and then posting the answers, what I've done is give you a study guide that already has the problems worked out for you. And you guys can just look that over and have.
We're doing a Kahoot.
You can even use it on the test. Can you believe it? So let's see, we got to mute a couple people because I think there's a, there we go. I think I got you guys muted there. All right, which if you need to say anything, I would love to hear from you guys. You don't talk too much anymore. So feel free to use this chat function or to, I will let you unmute yourself and say something if you need to say something. I'm just keeping you muted otherwise so that if there is, background noise at your house, we don't get that interference. But anyway, I was telling you guys about the test coming up and about this week, actually, in general. So we do not have any more new material. What you have been given is as far as we got in the force and motion unit. So I'm going to be testing you on that on Friday. There's a testing window for this. You have a history test that morning too. That's this Friday, the 22nd. So I believe the history test is from 9 to 11 a.m. I'm going to be helping Mr. Reese with that. So you may see me in the Zoom because that's on Zoom if I am not mistaken. My test will be open right after that. So at 11 o'clock, I will open my test on Socrative and I'll keep it open until 3. So that's a 4-hour testing window. Probably won't take you more than 30, 45 minutes maybe to take the test, maybe not even that. There is, I'm still tweaking it, but right now I'm looking at 25 multiple choice questions on it, and I might put 30. And so it will be done multiple choice. You do get to use your notes, and I have posted on Edsby answer keys to the labs. I have posted the answer keys to the notes. Not sure if I have the speed and acceleration notes posted. The answer key, I have the rest posted, and all the other answer keys are definitely posted. So use those, use them on the test if you want. But rather than looking at them on the test for the first time, use this week to start preparing and looking over these things, and use these 2 classes today and Thursday, our last 2 classes of the year. Use those to prepare. I have made a Kahoot game for you that we're going to play today. So hopefully you have a way to play Kahoot, maybe a tablet or a phone that is maybe in addition to the computer that you're using. I'm not sure actually if you can do the Zoom and use your computer as Kahoot at the same time. I actually think you can though. So anyway, I am, so I guess you probably can too. Okay, so that's what we're going to be doing today. I've also put together for you a slideshow of pictures that I took throughout the year and the school year, back when we were happy and in the classroom and doing our hands-on labs that, make my class fun. So I decided to share those with you on Thursday. That way I make sure that we get a good review in today, and I'll still make time for a review on Thursday as well. Don't forget, I do still have office hours today, Wednesday, Thursday. I don't think I will be able to have office hours on Friday morning because I will be doing proctoring the test. So no office hours on Friday morning. Okay, all right. So let's look at this study guide that I gave you guys. I posted it on Edsby on, let's see, when it was Sunday evening. Oh, Eva's still not in here. All right. Welcome, Eva. I hope you made it in. There is Eva. I saw you trying to get in a couple times. I thought I had admitted you. Okay. All right. So we are looking then, Eva, we were just talking about the test coming up this Friday. I will post, by the way, I don't think I mentioned, there will be a room code for Socrative, and I will post that on Friday morning for you, and then you'll have it on Edsby. It'll be on our Edsby page. I'll tell you it right now, too. It is Whaley 7481. So I will post that. You know what? I could even write it right here. I know you won't keep this probably, but it's right here. That's going to be the code. I will open it at 11 a.m. on Friday, this Friday, the 22nd. You'll put that code in and you'll be able to then put your name in and take the test. I will also post this code here on our Edsby page on Friday morning. Okay. All right, so go ahead and for today, you're going to want your force and motion study guide that I put on Edsby for you. Also, you might want to use other notes and other assignments from this unit. By other assignments, I mean, for example, the labs that we did. I posted the answer keys to that, plus you have your labs that you wrote too. You also would have your Angry Birds according to Newton, maybe handy. I have graded 5th periods, and I still need to work on finishing up 6th periods. However, a lot of you did not turn in Angry Birds. That was the last grade. The only other grade after our Angry Birds is the test coming up this Friday. So if you didn't get Angry Birds in yet, get that into me later today. All right, let's take a look at our study guide I posted for you. It looks like, I think it's this one, yeah. Okay, so you should be looking at the study guide. I will be able to pull mine up here in a minute. You'd think I'd be able to see it, but got too many other things in the way. All right, well, you're looking at it and, oh my gosh, it's like really all the way behind here. All right, I got it now. Okay, so, all right, so this tells you what is going to be on the test. And for those of you who might have missed the very beginning when I was talking about graded assignments, we're pretty much done with all of the assignments. I'm not giving you any more new work this week. So this study guide is not for a grade. However, it will prepare you for the test that is for a grade. These are the topics that are going to be on the test, these bullet points right here. So speed and acceleration. These are going to be math. You're going to have to be able to calculate speed and acceleration. But remember, you get to use your notes on the test, so you'll have the equations. You'll just have to plug things in. So make sure you bring a calculator, both today and also on the test on Friday. You'll need it. Also, you're going to be looking at net force, balanced and unbalanced forces. And then the net force is the total force acting on an object. So this is something we haven't gotten to practice with as much as I would like. So we will be practicing with that a little bit more today, and you'll see practice problems like that down here for it. We have Newton's first law, law of inertia, and Newton's second law, law of acceleration. the whole force equals mass times acceleration equation will have to be used and even rearranged to solve for other variables. But again, I've given you the notes and a little triangle that will help you do that. Third law, law of action and reaction, paired forces, equal and opposites. And then the fourth law, which was about gravity, universal or law of universal gravitation. And then finally, air resistance and terminal velocity and projectile motion. These last three topics were what we did last week during those notes that we did last week on falling objects. So where do we find all this information? Well, here's your resources that you already have available to you to use, and you can use them not only to study for the test, but also to use while you're taking the test. So those are your speed and acceleration notes, your Newton's laws notes. The lab activities we did. Gosh, we did Hot Wheels lab, we did Hula Hoopla, the Great Tankini, and Pennies from Heaven. Those are together. A Body in Motion. I feel like I'm forgetting one. But all of those, I've posted the answer keys. I also posted a PowerPoint on Edsby that goes through each lab and explains it on a slide. I think that would be very helpful for you to look over because what I'm going to be asking you to do on the test is basically apply this knowledge to objects in motion. So whether it's your labs or real world, applications, you should be able to apply these topics to objects in motion or at rest. Okay, so the notes on falling objects, which were last week, and then finally those Angry Birds assignments that you did. I posted also a document called Angry Birds Analyzed, and that is the answer key to the Angry Birds assignment. So you now have access to that as well. So don't be copying that and trying to turn it in as your own, but do please use it to make sure you're understanding how Newton's laws are exemplified in Angry Birds video game. All right. Any questions so far? No one is. Okay. All right. Not seeing anybody with questions. Okay. All right. Well, then I'll continue on. And remember, we're getting ready to play a Kahoot game here in just a minute. So having the study guide out will probably help you. Having any of these resources that we were just talking about, not only can you use them on the test and to prepare for the test, but you can use them right now too. So you might want to have them available. So how can you be successful on this test? Remember, this is your last grade. So for the most part, the grade you currently have in the class is your grade with the exception of this test. So I think I did mention that sixth period, I don't think I've quite finished grading all of your Angry Birds, but I know I have finished in fifth period. Even Jesse, you just turned somebody, I think it was Jesse, somebody just turned it in this morning, and I went ahead and graded that too. Sixth period, I'm not quite done with all of them, but once I am, that's your last assignment, and then you've just got this test, okay? So you want to do as best as you can on this test, especially if you are sitting kind of right at the cusp of a letter grade. So in order to be successful on this test, I've given you a few bullet points here for strategies. You're gonna need to be able to understand Newton's laws in order to apply the law when explaining the motion of the object. So although you are gonna be able to use your notes on the test, remember that although you will have the law stated, you do then need to be able to apply that law to explain the motion of other objects. Okay, so make sure you are understanding that. We're going to review that actually a little bit before we play Kahoot today. And you should also review the labs we did and Angry Birds so that you can feel comfortable with applying those laws of motion, like I explained you would need to do in the first bullet. Because most of the questions on the test are going to be like that.
Yes, sir. Two things. One is
Yes,
there's still.
Okay. All right, I thought Kate was talking to us there. Okay, so yeah, so the test questions are going to be like that. Those, excuse me, application type questions. So make sure you're feeling comfortable with that. We're going to have review games today and Thursday, and I will post these videos on YouTube like I always do, so you can watch them again later or attend them right now, or both. Okay, bring a calculator. There are going to be quite a few questions that you actually have to do calculations for. You're going to be surprised at how much math is on there. I know you guys don't love math, most of you. That's okay though. Don't be intimidated by it. It is pretty simple math. You're going to have to add, subtract, multiply, or divide. Nothing more than that. And the equations are going to be given to you. So all you need to be able to do is understand what to plug in for what variable, and then do the calculations on your calculator. So just bring your calculator. And then finally, first, or most importantly, show up. Don't not come to the test. I know that happened in a few other classes. I've got a 4-hour testing window. Make sure you're there from it. 11 a.m. to 3 p.m. Go to Socrative. It won't take you 4 hours. It'll take you less than an hour, I'm sure of it. But don't forget to go. All right? Okay. So the rest of the study guide are example problems. It will tell you if you notice here, you've got your equation for speed and velocity. And then you've got some example problems using those. And in red, you've got the answers of me working it out for you. You won't have to show your work on the test because it's multiple choice, but you'll need to know how to do the problem in order to answer it. And here's your acceleration equation. Okay, it tells you also what your units are going to be in. And here's your net force stuff. Okay. Then you're going to see some problems down here that are multiple choice. These are going to be similar to the ones you're going to see on the test. It's going to be this format, and you'll see they're worked out for you here too. And then finally got a little section here on Newton's laws and some answers. Okay, and more Newton's laws. And then this is the last page of it right here, I think, yeah. This is a little bit more math. This is Newton's second law, force equals mass times acceleration. But I've given you this triangle. Remember, you can use that to manipulate the equation, rearrange it to solve for other things. So for those of you not remembering how to use the triangle is a shortcut for using algebra and rearranging the equation to solve for something else. So force equals mass times acceleration. If you take mass and multiply by acceleration, you get force. But what if force is given to you and you're trying to find, and mass, you're given force and acceleration, you have to find mass. Well, you can rearrange that equation. How could you do it without algebra? Well, you could use the triangle, cover up the symbol for what you're trying to find. So if you were trying to find mass, cover up mass, and look at what's left over. You got your F and A, and F is on top of the A, so force divided by acceleration. Or if you needed to find acceleration and given force and mass, cover up acceleration, force divided by mass. And then of course, if you want to find force, cover up force. M and A are next to one another, you multiply them. And that's the original equation, Newton's second law. right there. You can do that. I think I gave you that triangle for all of your, all of these. Let's see, didn't I? I hope. Well, here's your triangle for speed. So you can find distance or time using that. And I think I didn't give it to you for momentum, although I could have, but I didn't give you any problems where you would have to rearrange it. I only gave you one momentum problem. So you just have to, you'll be given mass and velocity, and you'll just multiply them together to find momentum. Projectile motion, other than one equation that I will give you on how to calculate the speed of an object that, the final speed of an object that's falling, without air resistance. And then the last part of the projectile motion is just being able to understand the gist of it, that the horizontal motion, which is contributed to inertia, just continues on at the same speed, and vertically going downward, it accelerates at 9.8 meters per second squared. All right, there we have it. So that is my long-winded version of the study guide, going over it with you. It is your resource, use it. And let's get ready to play our Kahoot game. I think I'm gonna skip that slideshow on Newton's laws. I will do that with you on Thursday. That way we can make sure we get the Kahoot game done. Or if we finish Kahoot early, I can work on the other with you. Okay, so let's go back to me. Hi, everyone, again. All right, so got 16 of you here with us. Looking good. Let's see who joined us a little later. I think Toby came and joined us a little bit later, and maybe that was it. Okay, so go ahead and get your phones ready for, or your tablets, however you want to play Kahoot. I decided to do a Kahoot game instead of Jeopardy because I figured more of you could participate with Kahoot than you can with Jeopardy. And it's a little bit faster paced, so we get through more questions and get to review more material that way. So that's why I did that. Okay, so we are going to do that. Okay, hold on here. All right, let's see. I didn't have the internet pulled up, but now I do, so I think, let's see, we gotta play it. All right, we are going to play a live game together of this. And remember you are putting in your name for Kahoot, so I know who you are, not silly nicknames that might be inappropriate. I want to actually know who knows what. So use your actual name or an appropriate nickname that is obviously you. So here is your pin. All right, Joshua's playing. Okay, excellent. All right. Very good. Yeah, like Bryson Squid. I know it's you, Bryson, so I'll allow that. That's fine. Okay, cool. And the music is disabled in this when I played on Zoom for some reason. So for those of you that the music excites, sorry, it doesn't seem to play on Zoom. All right, let you guys get in here. And again, reminding you, there will be math problems on this Kahoot, just like there will be on the test. So have a calculator handy. And let's see, how many people do we have today? We have, I think there's 16 of you. So, okay. And I understand some of you might not be able to get on Kahoot. But I would be curious, is there anybody trying or even successful at being on playing Kahoot while on Zoom on the same device? Is anybody doing that right now, using the same device for the Kahoot and Zoom? Can I see if anybody is? Because I am curious if you can do that. Because I can, but I'm not playing the game, I'm hosting it. So Bryson is, okay. All right, so totally possible, yeah. All right, great, glad. All right, there's 8 of you. I know there are 16 of you in here. I don't know if everybody is playing. I give you guys about another minute, and then here in a second, I'm going to ask you guys if anybody needs more time, and you can raise your hand. If you don't, I'll start the game. There's 9 of you. All right, let you guys in. My door, hold on. Thank you. All right, I don't see any new people in there, so it must be time to start. Okay, let's see. All right, Nate's playing, yeah, on his computer too, using the same device. All right, here we go. So this is gonna be similar to the test, okay? These kinds of questions. Here we go. Oh, do you guys notice pictures of you there? All right, so the blank of an object consists of its speed and its direction. What do you think? Is it momentum, velocity, acceleration, or net force? Two seconds, and 2 of you didn't answer that one. Velocity is the correct answer, and only 1 person got that one right. Wow. Okay, so 4 of you thought it was acceleration. Okay, so remember, acceleration is how much an object is changing its speed. So acceleration is a change in speed. Speed and direction is velocity. All right, so let's see who got that one right. Oh, guys. All right, I won't say anything. All right, let's go to the second question. I'm feeling good about this one. What is the speed of a Vespa if it can make it to the Atlantic Ocean, which is 80 miles away, in an hour and a half? All right, so this is a speed calculation. Speed is distance divided by time. You got your distance, you got your time, use your calculator, you got 3 seconds. All right, and the correct answer was 53.3 miles per hour. 2, 3, 4, 5. Only 5 of you answered. That means 4 of you didn't answer that. It did go pretty quickly. I wonder if I can change the amount of time once the game has already started. I don't know that I can, but yeah, so got to be a little bit quicker about it. What you would have done with this one, of course, on the test, you won't have the pressure of having to be so quick. Take your time on the test. Your setup on this would have been your 80 miles, that's your distance, divided by an hour and a half. So who can tell me how they plugged that in? What did they do with an hour and a half? So it was 80 divided by what? Okay. No one? 80 divided by 1.5. That would be your hour and a half. Would give you your speed in miles per hour. Okay, let's see how we're doing. All right, Joshua, good job. Joshua's in the lead, followed by people without scores yet. So let's go to question 3. How long would it take you to drive to Key Largo, 310 miles, if you were driving at an average of 65 miles per hour? A little typo in there. Okay, so this one, you're looking for time. It's the speed equation. You're rearranging it. I told you how to do it already. T equals D divided by S, distance divided by time. I mean speed, distance divided by speed. Yeah, all right. A few more of you got that one. Those are quick. So 4 hours and 45 minutes. So you would have gotten an answer of about 4.7 when you did distance, 310, divided by speed, 65. So 310 divided by 65 gives you 4.77, I think, which would be 4 hours and 3/4 of an hour, which is about 45 minutes. All right. Let's see how we're doing. All right, good. Nate and Gunnar got there in the game, getting that question right. Good job, Nate and Gunnar. And Joshua's still in the lead. Okay. Usain Bolt holds the men's world record in the 100-meter dash at 9.58 seconds. What was his average speed? So distance divided by time. Distance divided by time. Distance, time. All right. Yay. 4 of you got it right. No. Oh, I'm sorry. I'm not looking at the right thing. 1 of you got it right. Oh, well, not so good. Okay, so I do see, though, that I tricked you a little bit. 3 of you did say 10.4, but notice that that was miles per hour. This was meters per second. And the speed here would have been in meters per second because your distance is in meters and your time is in seconds. So it was 100 divided by 9.8, which is 10.4. But watch your units. And I'm sorry, I tricked you a little there. Okay. All right. Gunnar just took 2nd place, knocked Nate down to 3rd. Joshua's still in the lead. And John Alexander and Bryson Squid are trying to get there on the leaderboard, but they don't have scores yet. So let's get some scores on there, buddies. All right, Bugatti Chiron, the fastest car in the world, one of them, can go from 0 to 60 in 2.5 seconds. What is its acceleration? Oh, I didn't give you the equation on there, but the equation is on your notes. Change in speed over time. So the difference in speed, 60 minus 0, divided by your time. All right, that's better. 24 miles per hour per second. That's right. So you would have done 60 minus 0, which is 60, divided by 2.5. All right, very good. And let's see what we got here on the leaderboard. All right. Oh, John Alexander's on there twice. I don't get that. Maybe you're in there. Maybe you're playing on 2 different devices because you get 2 different scores. Okay, so Joshua's still in the lead, followed by Gunnar, then Nate, and John Alexander is just behind Nate by 40 points. All right, guys. Number 6, net force is. What is the definition? Is it a force acting in the same direction as the object's moving? The combination of all forces acting on the object? A force acting in the opposite direction of the movement? Or the force of gravity pulling an object down? Net force. All right, well, a couple of you got that one. Looks like fairly even mix on some of these. So you guys knew that it wasn't the force of gravity. Nobody got tricked into that one. But some of you thought it might be a force acting in either the same direction or the opposite direction. Net force. Think about that word net there for a minute. It's like a network of all of the forces acting on the object. Now, if the forces are acting in opposite directions, so, you know, your arm wrestling with somebody and your forces are exactly the same, then nobody's moving, you would subtract those forces that are in opposite directions. And if they're in the same direction, two people are pushing something, you add them together. Um, and then the result of that is your net force. Okay, so you'll see a lot of sample problems like that on your study guide. That was the one that I said I didn't spend as much time on with you as I would have liked to. So trying to give you more practice on that this week. Okay, so John Alexander just took Gunnar out of second place there, bumped him down to third, but he's still on the board. Joshua Chow's got a pretty big lead there, followed by John and Gunnar and Nate and John Alexander number 2. All right, so question 7. An object experiencing balanced forces. So if the forces acting on an object are balanced, okay, then a net force is 0, object speeding up, object slowing down, the object stops moving. All right, well, fairly even mix between a red and green. So some of you thought that the object stops moving. Let me remind you that if an object is experiencing balanced forces, think about Newton's first law. It says that an object with without an unbalanced force on it will keep on moving in the same direction at the same speed, or if it's at rest, it will stay at rest. So basically, the law of inertia says that an object wants to keep on doing whatever it's doing if the forces acting on it are balanced, and it only changes what it's doing if the forces are unbalanced. So if it's balanced, it can't stop moving because then it's changed what it's doing. So same with speeding up or slowing down, that's changing its speed, right? So a object with balanced forces would not be changing its speed. It would not be accelerating, and it would have a net force of 0. So you will see a question a lot like that on the test. A lot like all of these, actually. All right, so Joshua's still in the lead, but Gunnar has just taken John Alexander and pushed him down a slot there again. So they're kind of going back and forth here. Nate is in third. So the rest of you still playing? Did I have some people drop out? I've noticed that I don't have all 9 people answering the questions anymore. All right. In a game of tug of war, one team pulls harder and wins the game. This is an example of what? Friction, momentum, balanced forces, or unbalanced forces. So remember, they're playing tug of war and one team pulls harder and wins. Unbalanced forces, there you go. Most of you knew that. And I stand corrected, all 9 of you are still playing. Yeah, okay, great. Okay, so leaderboard looks like it has not changed too much. Joshua's still in the lead, followed by Gunnar, John Alexander, and Nate. All right. Yeah, okay. All right. 9. How much force would be needed to accelerate a 30-kilogram ball 10 meters per second? Use Newton's second law. So force equals m times a. So there's your m, There's your A. Multiply them. And what'd you get? All right, most of you got that. That was 300 newtons. 30 times 10 is the force, and the force is in newtons. All right, good job, everyone, on that. All right, Joshua's still in the lead, followed by Gunnar. Ooh, Nate just pushed John Alexander down to 4th and assumed the 3rd place position. Not very far behind Gunnar. All right, you guys are pretty close there. Gunnar, Nate, and John. Let's see what we got next. Okay, we're a third of the way there about. All right, what's the acceleration of a 250 kilogram car if a force of 20 newtons is applied? So you rearrange the Newton second equation to solve for acceleration. F divided by M, force divided by mass. Force, mass. All right. Well, only one of you got that right. I don't know why. Okay, so yes, you should have done your force 20 divided by the mass of 250, and you would get 0.08. Looks like a pretty even mix between 12.5, which, if I am not mistaken, is the other way around if you did 250 divided by 20. 5,000, I think, was multiplying them together. All right, let's see what happened there. All right, John Alexander was the one to get that one right, it looks like. And otherwise, the board hasn't changed too much. All right, going next to 11. If a book weighs 6 newtons and the acceleration due to gravity is 9.8, find the mass of the book. So you are now rearranging the second law for mass. So it's force divided by acceleration. Your force is weight. Weight is a force of gravity acting on your mass. There you go. There's your force. There's your acceleration. Divide them. 0.61. All right, 2 of you got that one correct. 2, 3 did not, and quite a few of you didn't answer that one. I noticed that the ones that have math involved, a lot of you aren't, or not as many of you are answering it. I know that they're a little intimidating. Try them. If you keep practicing them, they'll be easier on the test, because I promise you they'll be there on the test. The good news about on the test, you won't feel the pressure and you won't have me talking over your thoughts. So maybe that will be helpful. But practicing them, I promise, is also helpful. All right, Gunnar Gunnar must have been the one that got that one right, one of them. So he has moved on up there to 44.69. Nate and John are not too far behind. Question 12. All right, a .150 kilogram baseball is pitched with a velocity of 43.2 meters per second. What's the baseball's momentum? P is momentum. M times V, mass times velocity. That's what you're doing. Mass, velocity, multiply. All right, one of you. Okay, let's see, a lot of you chose green, 6.8. I don't know why. Oh, that, no, I don't know. Okay, all right, well, let's see, who got that one right? Can't tell, it doesn't look like the board changed. All right, moving on. Number 13, what is the net force, which is this blue arrow after the equal sign you're going to see on the picture, between the wrestlers in the free body diagram? So it's basically, it's asking the net force, this arrow. So you got 3 newtons and 6 newtons, and they're in opposite directions. What are you going to do? 3 and 6 in opposite directions. Yes, correct. 3 of you anyway. 3 newtons to the left. How did this happen, or how did we get this? And I know the numbers were a little blurry here, which is why I said them to you. So they're in opposite directions, so you subtract them. So 3 minus 6 or 6 minus 3, either way you get 3 or negative 3. But in this case, your net force isn't really a negative number. It's going to be a positive number. So, but the negative will tell you kind of what direction, like it's in the direction of the bigger force. So since this is the bigger number, and notice the arrow is bigger, the force, the 3 newtons difference is in the direction of the bigger arrow. So that's why it's 3 newtons to the left. All right. Okay, let's see. All right. One John Alexander beat out the other John Alexander in that one. Okay, traded places there. All right, and ball is moving at a velocity of 30 meters per second east. If all forces acting on the ball remain balanced, what will the ball do? So it's moving at this velocity, 30 meters per second east, and all the forces acting on it are balanced. What's the ball gonna do? Stay moving at 30 meters per second east. That's right. According to Newton's first law, law of inertia, an object in motion stays in motion at the same speed and in the same direction unless acted upon by an unbalanced force. All right. Oh, Nate just bumped Gunner down on that one by two places. So Nate has moved into second place, followed by John Alexander and then Gunner. Joshua is still taking the lead by quite a bit though. All right, good job, Joshua, coming up 15. 2 people push a piano up a ramp with a force of 30 newtons each, but a force of friction 40 newtons is acting in opposition. What's the net force on the piano? Remember, add up the forces that are in the same direction, subtract the ones in the opposite direction, and what are you left with? Let's see how we did. All right, well, 2 of you figured out it was 20 newtons. All right, let me show you how you work this one. So, oh, this is covering up. Okay, well, in the picture, the picture isn't that helpful right now. Okay, so 2 people are pushing the piano up the ramp with 30 newtons each. So they're pushing in the same direction because they're both pushing up a ramp. Okay, so 30 plus 30, since they are in the same direction, that makes 60. Friction is acting against them. Remember, that's what friction is it's an oppositional force. Opposing the motion when 2 objects are sliding on top of, or past each other. So you're going to subtract the 40 newtons. So 30 plus 30 is 60, minus 40 is 20 newtons. All right. Let's see, Joshua knew that one. Getting up there over 10,000 points now, followed by Nate, John Alexander, and Gunner. But Trevor is having a streak. Trevor's streaking. He's going to make it up on this board. All right, question 16. Which will accelerate the most if all were given the same amount of force? All right, let's see. Mr. Reese in a shopping cart, Miss Hughes in a shopping cart, Olive Joe in a shopping cart, or a shopping cart full of 1,000 rolls of toilet paper. Which one will accelerate the most if they were all given the same amount of force? All right, one of you got that right. It's Olive. And if you don't know who Olive Joe is, and Joshua might not, that's our kitten. And the kitten has less mass than 1,000 rolls of toilet paper, or me, or Mr. Reese in a shopping cart. So if given the same amount of force, the object that has the least amount of mass would accelerate the most, according to Newton's second law. All right. Let's see how we're doing. Okay. Oh, John Alexander just took Second place bumped Nate down, and Trevor did make it up on the board, and he is right behind Gunnar by just a few points. All right, game's getting real. Okay, question 17. Which of the following is not true about large massed objects, such as this elephant? An object that has more mass has more gravitational force. An object that has more mass requires a larger force to make it accelerate. Object with more mass has more inertia, or an object with more mass is easier to make accelerate. Which one's not true? All right, two of you saw that the one that was not correct was the object with more mass is easier to make accelerate. We know that if it has more mass, it's harder to make it accelerate. But once it does, it wants to stay in motion more. It's got more inertia, so it's harder to stop. And it also has more gravitational force, and it would also require a larger force to make it accelerate. Okay. All right, so this is our gunner board. I was looking at Gunner's name, our leaderboard. We are at 11:53. I made this Kahoot pretty long. And so I think we aren't going to finish it. We're going to keep on going a little bit, and then we'll look at our winners from there. And on Thursday, we can play the rest of it along with the slideshow of the pictures and stuff I'm going to show you. So we'll just kind of split the Kahoot into two. All right, I think we got time for, maybe 3 more questions or so. Let's see, what number are we on? Number 18? I think we can get up to 20. In Angry Birds, a bird sits at rest in the slingshot. According to Newton, what must you do to make the bird move? He's sitting at rest. What do you have to do to make the bird move? 3 seconds. All right, you need to apply an unbalanced force to the bird, right? Which would consist of you pulling back the slingshot and releasing it, but that would deliver an unbalanced force to the bird. And most of you got that one right. Good job. Okay, oh, that changed some things. Oh, look, Trevor has made his way up into 3rd place. All right. Joshua in 1st, John Alexander in 2nd, Trevor in 3rd, Gunnar in 4th, and Nate in 5th place. All right. It's been changing up a lot, guys. Okay, last couple questions. Why did adding mass to the dishes during the Great Tankini make this trick easier? Was it because adding mass added extra inertia to the dish? Adding mass made the force required greater? Adding mass made the force required smaller? Or adding mass gave the tablecloth extra inertia? What made this trick easier? All right, most of you got that adding mass added extra inertia to the dish, which is what you want, because inertia means it's the object's propensity or likelihood that it's going to stay doing whatever it's doing, not changing. And you want that dish to stay on the table at rest. So if it has more inertia, it's more likely to stay at rest. Yes, you have to pull the tablecloth with more force, but that doesn't make it easier. What makes it easier is the fact that even though you're pulling it with more force, that's the cloth. The dish, you're not pulling on the dish, well, a little bit because of friction between the two. But if you pull with enough force, then you'll overcome that friction and the pan will stay put. Okay, so I think we're on question 20. Is that the case? Yeah, let's do this last question. A rocket releases or pushes gas downward. According to Newton's 3rd law, what's the equal and opposite reaction? Is it that the rocket accelerates up, the gas pushes up on the rocket pushes up on the gas, or the rocket falls to the earth? The equal and opposite reaction to the gas, to the rocket pushing down on the gas. There you go. 2 of you got this one right, and this was a hard question. The gas pushes up on the rocket. Pardon me. That was Newton's 3rd law. The one that I've told you a couple of times is the most misunderstood law. The pairing of the forces tends to give people a hard time. A lot of people will say, okay, well, if the rocket pushes down on the gas, then the equal and opposite reaction is that the rocket goes up. The result is that the rocket goes up, but the force, remember the action and reaction are about forces. So if the rocket pushes with a force down on the gas, then the gas pushes up on the rocket. Why does the rocket accelerate upward? Because the gas is the unbalanced force that is pushing the rocket up. You might say, but wait, isn't that a balanced force? Because you're just saying they're balanced. Those are balanced forces, but remember, they're not acting on the same object. One's acting on the gas. The rocket is pushing on the gas is pushing on the rocket. Nothing else is pushing on the rocket except the gas, so the rocket's going to go up. I mean, there is gravity. There are other forces, but the force of the gas pushing on the rocket is greater than the weight of the rocket, which is gravity pulling it down. Okay, it's needs a little practice probably. Let me stop my share here. Oh, let's look at the leaderboard. Okay, so here's our final results on this. We've got Joshua in first place, John Alexander in second, Trevor in third, and Gunnar in fourth, and Nate in fifth. Awesome job, guys. I'll take a picture of that. What am I going to do with that? I'm not exactly sure. Giving dojo points doesn't matter anymore at this point. Maybe extra credit or something I could put on there a little bit. But it also means you're prepared for the test. So good job, guys. I'm going to finish this remaining ones on Thursday along with our slideshow of fun pictures and a Newton's Law little review as well. So don't forget to study this week. Come see me during office hours if you have any questions, or send me a message on Edsby if you prefer. And I will talk to you guys real soon. All right. Take it easy, guys. Bye now.